6,128 confirmed planets orbiting other stars, and that number is already out of date. At least 100 billion more sit undiscovered in our own galaxy, according to NASA's working estimate. The instrument built specifically to find a signal among them, Breakthrough Listen, is sensitive enough to catch an ordinary aircraft radar broadcasting from any of the 1,000 nearest stars to Earth. And after 66 years of listening, across every radio telescope ever pointed at the sky for exactly this purpose, the result is 0 confirmed signals. Most people hear that and relax, which is exactly backward. I used to relax about it too, until I actually worked through the reasoning professional astrobiologists use to interpret that silence. It runs the opposite direction from the instinct. The longer the sky stays quiet, the worse the news gets, specifically for us. And the day it stops being quiet might turn out to be the single most dangerous day in the history of our species, for reasons that have nothing to do with spaceships or death rays. If you're the kind of person who thinks seriously about this topic, somewhere in the back of your mind is a specific, comforting belief that if we ever got hard confirmation of an intelligent civilization out there, it would be one of the best days in the history of science. Proof that minds like ours aren't a fluke, that whatever we are, we're built to last. You'll hear versions of it from working scientists as often as from science fiction fans. Intelligence signals hope, distance signals safety, and information can't do what only weapons can. I want to take that belief apart, piece by piece, because it's wrong in more specific, mechanical ways than most people assume, and every one of those ways matters. Let's start with where this question actually comes from, because the popular version of the origin story is wrong in a way that matters later on. Summer of 1950, Los Alamos National Laboratory. Enrico Fermi is walking to lunch with 3 colleagues, Edward Teller, Emil Konopinski, and Herbert York, men who had just finished building the atomic bomb. They're talking about flying saucers, because there'd been a wave of UFO sightings that year, and somebody brings up a New Yorker cartoon from a few weeks earlier showing little green men stealing New York City's public trash cans. Everyone laughs. Then, in the middle of an entirely different conversation, once they'd sat down to eat, Fermi asks, "Where is everybody?" Popular retellings turn that into prophecy. The great physicist, staring into the void, sensing that we're alone. That isn't what happened. We only know about the remark at all because a Los Alamos physicist named Eric Jones tracked down the 3 surviving witnesses in 1984, 34 years later, and asked them to write down what they remembered. What they described was narrower and more interesting than the legend. Fermi wasn't making a claim about whether extraterrestrials exist. He was doing rough arithmetic about interstellar travel. If a technological civilization can eventually spread between stars, and the galaxy has been around long enough for that to have happened many times over, someone's colonists or machines should already be here. They aren't. So, where is everybody? That phrase didn't even get labeled the Fermi Paradox until 1977, 27 years later. And it didn't get a rigorous, falsifiable structure until 1998, when an economist named Robin Hanson, not an astronomer, an economist at George Mason University, published an essay called The Great Filter. Are we almost past it? This is the piece almost nobody outside the field has actually read, and it's the piece that flips the emotional charge of this entire topic. Give me 2 minutes on the actual mechanism, because the vibes-only version everyone repeats gets it backward. Here's Hanson's setup. Getting from dead chemistry to a civilization capable of spreading through the galaxy takes a sequence of hard steps. Hanson counted roughly 9 of them. The origin of self-replicating molecules, the jump from simple to complex cells, the jump from single cells to bodies made of many cells, the evolution of tool use, and eventually industrial and interstellar technology, among others. Each step, as far as we can tell from the only example we have, is difficult. Some might be almost impossibly difficult. Somewhere in that chain of 9 locks, there's at least one whose odds are so bad it filters out nearly everyone who starts the run, which is exactly what you'd expect from a galaxy with 100 billion planets, and, as far as we've ever managed to detect, nobody home. Hansen named that bottleneck the Great Filter. Hansen illustrated the trap with a simple thought experiment about picking a set of locks under a time limit. If all you can see is which locks eventually got picked, not how many silent failed attempts each one secretly took, you can't tell the easy locks from the brutally hard ones just by looking at your own track record of eventual success. The fact that a step in our evolutionary history eventually happened tells you far less than people assume about how likely it was to happen at all. It only tells you it happened this once, in this one data point, which is us. Now here's the question that actually matters, and it's the one most people skip straight past. Is that filter behind us, or still ahead of us? If the hard step is behind us. If, say, the jump from simple chemistry to the very first living cell is the 1 in a trillion event, and we already cleared it 4 billion years ago, the silence out there is genuinely comforting. We got the impossible part over with already. Everything after that, tool use, industry, spaceflight, is comparatively routine, and our future stays wide open. But if the hard step is still ahead of us, if life and complexity and even intelligence turn out to be routine, and the actual bottleneck is something more like civilizations that invent industrial technology reliably destroy themselves before they get much further, then the silence means something much colder. It means we haven't hit the wall yet. It means whatever kills nearly everyone is still in front of us, not behind us, and every additional year of quiet sky is 1 year closer to finding out what it is. Nobody knows what that specific mechanism would be, but it doesn't take much imagination to list plausible candidates from our own headlines. Engineered pathogens, runaway artificial intelligence, a nuclear exchange, a climate collapse nobody manages to reverse in time. The Great Filter doesn't require a villain. It just requires that industrial civilizations, on average, hit something they can't survive shortly after they get the ability to broadcast their own existence, which is, uncomfortably, exactly the stage we're at right now. This is exactly why, in 2008, the Oxford philosopher Nick Bostrom wrote what might be the strangest essay ever published in a mainstream technology magazine. It ran in MIT Technology Review under the headline, "Where Are They? Why I Hope the Search for Extraterrestrial Life Finds Nothing," and the argument gets more disturbing the more specific the discovery gets. Give it 90 seconds, and you'll see exactly why serious astrobiologists still cite this piece almost 2 decades later. Bostrom was writing right, as NASA's rovers were confirming that Mars used to have liquid water on its surface, and the public mood at the time was pure excitement. Water means life might have existed there too, and any hint of a second, independent origin of life would be one of the great discoveries in the history of science. Bostrom argued we should actually hope Mars turns out to be sterile, not for any aesthetic reason, because of exactly the logic we just walked through. If Mars once hosted simple microbial life that started completely independently of life on Earth, that tells us abiogenesis, the jump from chemistry to biology, isn't the hard step. It happens routinely on any wet rock with the right chemistry, which means the Great Filter has to be hiding somewhere later in the sequence. Bostrom's rule was blunt. The more advanced the fossil, the worse the news. Simple bacteria would be moderately bad. Something like a fossilized multicellular organism would be considerably worse, because it would mean evolution can climb higher than we assumed before something stops it. And whatever that something is, we haven't met it yet. Run that same logic forward to an actual detected signal from an intelligent, technological civilization, and you get the sharpest version of this argument in the entire topic. A signal doesn't just tell you life is common. It tells you intelligence is common, tool use is common, building a transmitter powerful enough to cross interstellar distance is common, and that despite all of that, the galaxy still looks empty and quiet to everyone else out there too. Every step we assumed was the hard part turns out to be easy, which leaves exactly one place left for the filter to hide, at or beyond our current stage of development, right where we're standing, or just past it. A microbial fossil only proves biology is easy. A confirmed, decoded signal from another mind proves that the entire staircase, biology, complexity, cognition, culture, and technology sophisticated enough to broadcast across light years, is climbable. That's not a small upgrade in bad news. That's nearly the whole staircase confirmed passable, with only the top floor left unaccounted for. That's the first correction, and it's the one that actually matters most. Contact with an intelligent civilization would not be reassurance that beings like us can make it. Depending on exactly what we found, it could be closer to a diagnosis. Even people who accept every word of that argument tend to fall back on a second comforting idea, and it deserves the same scrutiny. It goes, fine, detecting a signal might be statistically bad news in the abstract, but detecting isn't the same as being harmed. We wouldn't be doing anything. Listening is passive. A radio wave landing on a dish in West Virginia can't reach out and hurt you. It's not as if opening an envelope kills you before you've even read the letter inside. That analogy is backward, and the reason has a name. Richard Carrigan, a physicist at Fermilab who spent years combing infrared sky surveys for the waste heat of alien megastructures, published a paper in 2006 with a title that sounds like a joke and isn't, "Do potential SETI signals need to be decontaminated?" His argument is simple enough to state in one line and unsettling enough to be worth sitting with. Letters absolutely can hurt you if what's inside is a set of instructions and you're the one who decides to follow them. Here's the actual math, because this is where it stops being philosophy and starts being engineering. Using radio technology only a modest step beyond what we already operate, Carrigan calculated that a transmitter comparable to a receiver's could push more than 10 kilobytes of data per second across 50 light years to a receiver our size. At that rate, a full gigabyte, a complete piece of software, an entire technical encyclopedia, arrives in under a day for an energy cost of a few $1,000s. That's not a beacon blinking hello once every few minutes. A civilization only slightly ahead of us could hand over an entire library before you finish your coffee on the very first attempt. The obvious objection, you're probably already forming it, is that this doesn't matter because alien code can't run on human computers. Different architecture, different logic, no socket we built for it to plug into. Carrigan's answer is that the danger was never a virus jumping our firewall. It's us. It's a research team spending a decade painstakingly decoding a transmission, finding what looks like a blueprint, a new material, a cure, a more efficient reactor, an intelligence architecture more capable than anything we've built, and choosing, voluntarily, enthusiastically, competitively, to construct it, without any real way to verify what it does once it's running. Nobody has to hack anything. We would be doing the building ourselves, out of curiosity and ambition, exactly the way we always do. This isn't even a new category of attack, just a much bigger version of an old one. The overwhelming majority of real-world cyber attacks today don't defeat a firewall with clever code. They defeat a human being who clicks the attachment, runs the installer, or trusts a login page that looks slightly too perfect. Carrigan's scenario is that exact weakness, scaled up to interstellar distance, and dressed in something no research team on Earth would have the willpower to leave unopened. Actual, verified, no longer hypothetical proof that we are not alone, delivered alongside a gift that seems to prove it was worth finding out. Notice what that does to the emotional shape of the danger. It doesn't require hostile aliens. It doesn't require any intent at all, benevolent or otherwise. A sufficiently advanced set of instructions is dangerous to a civilization that can't fully evaluate it before acting on it. The same way a piece of hardware from 100 years in our own future would be dangerous handed to Victorian engineers, even with a friendly note attached. The threat was never malice. It's the gap itself. Now here's the part I have to be honest about, because it's the one place in this whole argument where I've personally changed my mind, and where the record is genuinely still open. You'd think, with all of this at stake, that recognizing a real signal would at least be the easy part, that whatever else is uncertain, the moment of detection would be clean. It isn't. And the best illustration of why is sitting in a filing cabinet in Ohio, August 15, 1977. The Big Ear radio telescope outside Delaware, Ohio picks up a signal from the direction of Sagittarius. 72 seconds long, narrowband, sitting almost exactly on 1420 megahertz. The hydrogen line, the specific frequency SETI researchers have treated as the most logical spot for an alien beacon since the 1950s, because hydrogen is the most common element in the universe, and any civilization doing radio astronomy would stumble onto that number too. A volunteer named Jerry Amon found it days later, reviewing a stack of paper printouts, circled the 6-character readout, 6-5, in red ink, and wrote one word in the margin. That word is now the name of the event, the WOW signal. For years, I told people the tidy version, probably a comet, case closed, nothing more to see. That comet explanation got real traction in 2016, when astronomer Antonio Paris proposed that a couple of comets happened to be crossing that patch of sky and their hydrogen envelopes lit up at the right frequency. It's a satisfying story because it closes the question without needing aliens or an open file. I was wrong to repeat it as settled. Most working radio astronomers, including Amon himself, never actually accepted that explanation, largely because comets that dim don't produce anywhere near that kind of signal. What actually moved my confidence wasn't the comet theory at all. It was a study published last year. A team led by astrobiologist Abel Mendez went back to the original 1977 hardware, recalibrated it using modern methods, and found the signal was considerably stronger than the number that's been repeated in almost every retelling of this story for nearly 50 years, mine included. The figure that gets quoted everywhere is 54 Janskys. Mendez' team's revised number is at least 256. Their leading explanation now isn't aliens, and it isn't a comet either. It's a cloud of interstellar hydrogen gas, sitting quietly for millennia, suddenly slammed by a burst of radiation from something like a magnetar, briefly forced to glow at exactly that frequency like an enormous natural laser flashing once. It's a genuinely elegant idea. It's also, as of this year, still unconfirmed, still argued about, and still hasn't produced a second event anyone can point to and say, there, caught it happening again. Almost 50 years later, our own instruments still can't tell you with full confidence what produced 72 seconds of data from a defunct observatory. It isn't because the equipment was primitive. It's because separating artificial from a genuinely novel natural process we've simply never cataloged before turns out to be much harder than the tidy detective story version of SETI implies. Both categories, an engineered beacon and an exotic astrophysical flare, tend to look identical on paper, narrow in frequency, brief, and bright. The universe turns out to be a much better forger than science fiction gives it credit for. And this isn't even the first time ambiguity like that has fooled careful people. 10 years earlier, in 1967, a Cambridge graduate student named Jocelyn Bell Bernal found a radio source pulsing with such mechanical precision that she and her supervisor briefly, half seriously, filed it under LGM, for Little Green Men, before working out that she'd discovered an entirely new class of star. If confirming an unambiguous signal from 1977 still isn't fully settled today, the idea that we'll calmly and unanimously recognize a real detection the instant it happens, with enough certainty to act carefully, is optimism dressed up as confidence. Which brings us to the step that actually converts all of this from an abstract worry into a live, ongoing decision. It's one that, it turns out, doesn't wait for consensus, because it's already been made, more than once, by people nobody elected to make it. The first deliberate transmission humanity ever sent happened on November 16, 1974, when Frank Drake and Carl Sagan used the newly upgraded Arecibo telescope to beam a 679-bit message at the globular cluster meters 13, 25,000 light-years away. It was a genuinely symbolic act, a public ceremony, a rededication, a postcard nobody expected an answer to inside multiple human lifetimes, since a reply couldn't arrive for 50,000 years. Right now, in 2026, that message has traveled about 52 light years, 52 out of 25,000. We are exactly at the beginning of this. You'd assume, reasonably, that if humanity ever picked up something real, there would be some kind of careful, coordinated process before anyone replied. A global conversation, at minimum, before a single word went back out. There has never been such a process, and there isn't one now. In 1999, a team of radio astronomers at the Evpatoria Planetary Radar in Crimea, led by a scientist named Alexander Zaitsev, beamed a message called Cosmic Call toward 4 nearby sun-like stars. This time with no ceremony and no consultation with the broader SETI research community first. There was no rule requiring them to ask. They had a working transmitter, a target list, and the will to press the button, and that turned out to be sufficient. Scholars who study this exact problem borrow a phrase from a completely different field to describe it. The tragedy of the commons, the same dynamic that overfishes a shared ocean or pollutes a shared river. Earth's collective anonymity is a resource every human being currently shares equally, whether or not they know it, and it can be spent in full by anyone with a big enough antenna, regardless of what the other 8 billion of us would have voted for. In October 2017, a separate organization sent another deliberate, information-rich message toward Luyten's star, 12 light-years away, from a radar facility in Norway. If a reply came back the moment it was received, the earliest we could possibly hear it is about 25 years from the transmission date, which tells you something important. Whatever gets decided about announcing ourselves this way plays out on a timescale no single government, and often no single scientist's career, will ever see resolved. Stephen Hawking spent his final years warning, publicly and consistently, that this specific move, deliberately transmitting, not just listening, was the genuinely reckless one, drawing a comparison to what tended to happen when technologically mismatched civilizations met throughout human history. The comparison was never really about malice on either side. It was about what happens, mechanically, when there's a large gap in capability between two parties and one of them doesn't yet know the other exists. In case after case, the damage wasn't a battle. It was the quiet stuff. Diseases the newly contacted population had no immunity to. Economies reorganized overnight around the visitor's priorities. Information advantages exploited long before anyone raised a weapon. None of that required the more powerful side to be evil. It only required the gap to exist. A scientist named David Brin has been making a version of this same argument in the scientific literature since 1983, and it's telling that even the people funding the biggest listening search in history seem to agree there was something categorically different about talking back. The same 2015 announcement that launched Breakthrough Listen also launched a sister project, Breakthrough Message, a competition to design a message representative of humanity, and its organizers wrote an explicit promise into the program itself. They would not transmit anything until there had been a global debate about the risks. The listening half of that initiative never had to make that promise. Only the talking half did. That asymmetry, buried in a funding announcement, is basically the entire argument of this video compressed into one clause. And this is the piece that closes the loop on everything else. It isn't that a hostile fleet is sitting in the dark somewhere, waiting for a return address. It's that becoming detectable, unlike almost every other consequential decision our species makes, has never actually required our species to agree to it. One radio telescope, one motivated team, one grant, and Earth's silence. The exact silence Robin Hansen's great filter logic says we should already be nervous about, has been unilaterally, quietly broken multiple times by people acting on their own judgment about a decision that, if it goes wrong, everyone else pays for too. Put those three pieces next to each other and you get something more precise and more interesting than the aliens might be dangerous. Headline this topic usually gets reduced to. The statistics say a confirmed detection could be evidence that whatever kills advanced civilizations is still ahead of us, not behind us. The information itself, entirely apart from any spacecraft, can function as a weapon the moment we choose to build what it describes, no malice required from anyone. And the decision about what to do next, whether to answer, how loudly, how much to reveal, has never been governed by any process that guarantees caution, because it never has been before. None of that requires imagining hostile extraterrestrials at all, and that's the part that took me the longest to actually sit with. Every mechanism I've walked through today works even in a universe where every other civilization out there turns out to be, on average, perfectly indifferent to us, the way we're indifferent to the exact bacteria living in soil we've never bothered to test. Indifference, at a large enough gap in capability, produces the same outcomes malice does. That's not a metaphor. It's closer to a load-bearing fact about what contact between mismatched civilizations actually looks like, in physics and in history both. Every mechanism in this video runs on statistics, information theory, and plain human curiosity, not on anyone, anywhere, wishing us harm. Here's what actually connects this back to something larger than telescope budgets and 49-year-old printouts. We are, right now, simultaneously the only working observer of this experiment and one of its data points. Every year the sky stays quiet is a year of evidence slowly accumulating about our own odds. Not proof of anything by itself, but a number very gradually updating in a direction none of us will live to see the end of. At the exact same time, we're running our own trial inside that experiment, building bigger transmitters, designing brighter messages, writing promises into competition rules about when it might someday be acceptable to press send. We are the astronomers in the experiment, watching an outcome that includes ourselves, using a method that requires us to stay rational about a decision with a payoff horizon measured in tens of thousands of years and a downside we get exactly one attempt to avoid. No other experiment in the history of science has ever asked its own researchers to also be the subjects, running an irreversible trial on themselves while trying to interpret the results with a clear head. So when someone tells you that finding intelligent life out there would be the best day in human history, proof we're not alone, vindication that minds like ours can actually make it. Remember where that comfort actually comes from. They all laughed at the cartoon that day in 1950. Only one man at the table was already doing the arithmetic. Every comforting theory about first contact since has been the laugh, not the math.